All right, good afternoon everyone. We are now dealing with lesson on proportions. Okay, so this one, it has something to do with measurements as well because of the unit conversion. Conversion factor is a ratio. It has something to do with ratio as well because it always has that fraction numerator and denominator, right? But in here, for proportion, we're taking a look at that one in terms of like an equation, right? A ratio on the left and a ratio on the right. It can also be a two-column, like what we call a column form of proportions. But anyway, let's read what our objectives are for this one first, okay? Drew, go ahead. Solve
Application problems using proportions.
Thank you. Okay, so what we notice in here are some application problems involving what? Scale factor. What is this? Miles per gallon, okay, of gasoline, okay, and such. So let's read this one first on architectural plans, okay. So let's read this first and see how we can work on this one, guys. I guess it doesn't work like that. All right, let's read this one in here. Scale. Okay, go ahead, River.
Oh, just the whole thing?
Yes, please.
Okay. The scale on the architectural plans for a new house is 1 inch equals 7 foot. Find the length and width in feet of a room that measures 8 inches by 9 inches on the drawing.
All right, so typically this is what we call the blueprint. Okay, anyone who's familiar with blueprint? Right, like a house plan, it has a blueprint. So typically, you would draw that one by scale. Okay, whatever is in the blueprint, it has what we call a scale factor. Okay, so in here it says what? For every inch on that blueprint, it's what? A 7 feet length. That's the scale factor. Find the length and width in feet of a room that measures 8 inches by 9 inches on the drawing. Okay, so how do we do this first? So as you may notice in here, step number 1 for our problem. What is that? Dante.
Oh, variable.
Represent a variable. Okay, so as you may notice in here, and taking a look at our problem solving in the past as well, C means what again? Circle the numbers. So what are numbers that we circle? 1, 7, 8, 9. Okay. You underline what is being asked. And what is being asked in here?
To find the length and width.
Find the length and the width. Okay, very good. B, box the keywords and phrases. So what are the B's in here? Well, 1 is in inch, 7 is in feet. Okay, yeah, good. And that's the what? That's the scale. Okay. What we call scale factor as well. Okay, drawn to scale. What do we need to find? Length and width in what? Feet. Okay. The 8 and 9 is what? Both in inches of what? A room. In the what? In the drawing. Right? That's your P. Now let's make an equation out of that. And again, if we make an equation, we need to have a variable. So what variables do we have in here? What we have are as follows. What is that? Length. Okay. L for length. And width is what? W. Okay, so check step number 1. We need to represent a variable in here. Find the length, let's call that L. Find the width, let's call that W. Okay. Okay. Now what does it say on that one? Set up a proportion equation. Okay, so that's your step number 2. What is the proportion equation for length? When it says in here for the length, what did it say? Length is to what? 9 inch. Okay. Why is it 9 inch, not 8 inch? Guys. Why did we relate the length with 9-inch but not the 8-inch? Anyone? It's a good question, right? Can we just interchange them? Why not?
She has the answer.
No, I don't. I'm just.
Give it a try.
Anyone? Why is length the 9-inch but not the 8-inch? Any idea? Just
I don't know. Is it because of why not?
well, here's the thing, right? If you already have two variables, length and width, typically the length is always the what? The longest.
Yeah.
The higher value is always the length. That's why it's called length. That's the longest. Okay?
Okay, yeah.
Good.
Nice.
Typically the width, well, if you have width and height, typically the height is the what? The one that's vertical. Okay? If it's situated above. Okay? We good?
Yeah.
So again, the length is typically the longest. That's why in here, you would choose length to be what? The bigger number.
9.
That's why it's length, longer, longest. Okay. The height is typically the one vertically situated, right? And the width is, well, none of those two. You good?
Yeah.
Get it?
So how would height show up in an equation like that?
Well, if it says length, width, and height, then you would know that one of those should be the height. Okay. Good.
So do you mean like cubic feet for a room?
Well,
And typically
like-
the height, well, we're going to go there during that problem, but typically the height, either it's given on the problem or given on the drawing. You have a drawing and you would see on the illustration that that is the height. Why? Because it's vertically situated, right? Either or. Anyway, going back in here, we're just talking about length and width. So what do? Well, length is to 9 inches as to what? Well, according to this is your conversion factor now, right? Your scale factor. And what's your scale factor? Well, length in feet, this is in feet, is to 9 inches as to what? Well, every 7 feet is to 1 inch based from the what? The scale factor. Okay? So that's your equation for the length. What about the width? Well, we say what? Width is to 8 inches. Width in feet is to 8 inches. As to, again, this is again the scale factor.
Okay, you just said it.
Okay. Where's that scale factor? Well, it says that every 7 feet is what? 1 inch. As you may notice in here, this is in feet, right? If you have the feet on top, then this on the second part, the right side of the equation has the same. Feet on top as well. The inches below should always also have the inches below. So you cannot flip this. Okay? So feet is to feet, inch is to inch. Good. So again, that is your what? Set up a proportion equation. Okay? And then after that, what do we do next? Multiply both sides by the what?
Least common.
Least common multiple. Alright? Or sometimes called the least common denominator as well. Okay? So in here, what's the LCM? Or LCD. This is 9 and that is 1, which means what is the least common denominator between 9 and 1?
9.
Very good. 9. And might be think, Mr. Deal, how do we even know that? Well, Desmos can help you out with that. Okay, Mr. Deal, I mean, I don't even know what's the LCD. So here's what you're gonna do. Click on the tools. Follow me, guys. Click under functions. If you recall the GCD last time, that's like GCF, greatest common factor. Beside that is the LCM. Okay. So under number theory, you see that LCM? Yep. Click on that. Okay. So click on that. Okay. Again, this is also pairwise, just only for 2 numbers. Okay. So if you have 3, you get the LCM with the first 2, and then get the LCM with the third. Okay. Anyway, so in here, what's those 2 numbers? 1, comma, 9. Oops, not dot, comma, 9. Get it, guys? How we get the LCM? Or the LCD? Right. So the LCD is the what? The least common multiple of the denominators. Okay? Least common denominator.
What would be the manual way for that? For just any given pair of numbers?
Well, again, when you say multiple, you just multiply them anyways, right? If they're relatively prime. Okay? Good. So that'll be 9, and do the same for the rest. Okay, so with that being said, the LCM in here are both 9. So what do I do in here? Multiply both by the LCD, which is what? 9 again. Right. So multiply this by 9, and the same multiply this by 9. Okay. And do the same in here, since they're the same anyway. Oh, well, this one is 8 and 1. So what's the LCM between these two then?
You said 8 and
8.
1.
Very good. And yes, you can get your next one now. Multiply both sides by the LCD. What's step number 4? Cancel common factor and what is that again? Let's see. Oops. Cancel common factor and let's go back in here. Okay. Cancel common factor and unit. Perform your order of operations, your parenthesis, exponent, multiply, divide, and subtract, and solve for the variable. Okay, so let's do that one in here. Go back in
Wait,
here.
what was the last one?
Should have copied that one, guys, on your end, right? Solve for the variable. Okay, that means solve for L and solve for W. Get it? Okay, so let's see. What is it? Let's see in here. So this will cancel out. Okay, so you just have your L. What is that? What's your L now? What's 7 times 9? Calculator?
7 times 9 is 54.
54?
Wait, 63.
63. Okay, there we go. And as you may notice in here, the unit is in feet. Okay. What about the width? What is the width in here? The 8 will cancel out in here on the right, on the left. On the right, what is this? 8 times 7. 56. And again, you can manually compute for that. You also have your calculator for that. Okay. And that one is your 56.
So with the LCD step, which two units do we multiply?
Yeah, that's correct, right? It's a good question in here. So this is like 8 inches. So basically, you're gonna put 8 inches in here. Those inches will cancel out as well. And what you see in here, what remains is the feet instead.
Okay.
Okay.
So-
And same in here. Okay, 9 inch. The inches will cancel out. If you just want to look into that unit dimension analysis, and you have the feet unit remaining in there. So the answer will be the following. The length is the bigger number or longer side, 63 feet, and the width is 56 feet in there.
What if 7 feet was equivalent to 2 inches? Like if we just switched out the 1 inch for 2 inches rather than.
Mm-hmm. Yeah. So this one, 7 feet is to 2 inches.
Yeah.
Now after that, again, if that will be the case, if this is 2, what do? Well, you get first the LCD between 9 and 2,
Okay.
8 and 2, which definitely is not 9, also not 8. Okay, so that will be the case. But again, the same solution, but certainly if should that be 2, then that means the LCD will change as well.
So it would
Okay.
be 18 times whatever the top number is.
Okay.
I have another question.
Sure.
How do you know which number goes on top? Like feet?
Oh,
inches?
okay. Good question, Victoria, right? How do we know which number goes on top? Well, according to our problem, what unit is the top priority?
The one we're finding. Or the
Yeah,
one
what
with
unit
the
is in there? It says what? Length and width in what? Feet. Okay, so that means your feet should be once again, the top priority. Like literally on top.
Okay.
We good? Right. So again, still the same with our ratio, right? If you recall the ratio, we still have the struggle of like, what should be on top and what should be below again? Again, what do we say? Well, the one on top is the one that we need that unit. Okay? And typically the one below is the unit that is given for us. Okay? Alright, so in here, one last question, and let's see this one. This is the mileage or miles per gallon. Okay? Anyone can read it for us, please? Victoria, can you see it from there? Thank you.
If your car can travel 70.5 miles on 3 gallons of gasoline, how many miles can the car travel on 28 gallons of gasoline under the similar driving conditions.
Thank you. Okay. So, as you may notice in here, we circled the following: 70.5, 3, and 28. Okay. We underline the question. What's the question? How many miles can the car travel at that much gallons of gasoline? Okay. Good. So that's your U. B, box the keywords. 70.5 is the miles. 3 is the what? The gallons of gasoline. What's we're asking for? The miles, okay? And this is the gallons again, okay? That's box, the keywords and phrases. Now we make our equation. Step number 1, represent a variable first. So how do we represent miles? Well, we say in here, let M be the miles driven. Okay. Why do we say that? Because that's what's being asked. How many miles will be driven on that gallons of gasoline? Okay. Next, step number 2, set up a proportion equation. Well, we say now what? Well, miles driven for a what? 28 gallons. You good? Yeah. So miles driven on a 28 gallons should be equal to what? Well, according to this conversion, that's 70.5 miles for every 3 gallons of gasoline, right? This is typically the what? This is typically the miles per gallon. If you can recall that, right? Good. Okay. Again, the question a while ago, why do we know that the miles should be on the top, not the gallons? Because according to this, according to the question, what are you wanting? You want the miles. So whatever the unit needed should be the top priority, right? That's why they're on top. M what? M miles. Okay. So that's your proportion equation. Okay. A ratio on the left, a ratio on the right, and then there's an equal sign. That's why it's an equation. Okay. Get it. As you may know, the miles are both on top because they're the needed unit. The gallons are below because they're also given. Okay. After that, what do we do? Multiply both sides by the LCD. What's the LCD in here, guys? Let's look. 28 and 3. What's the 28 and 3? What's the LCD? Putting it in here. You see this LCM a while ago? I can basically reuse this, all right? I'm going to put in here what? 28, comma 3.
84.
Very good, right? Okay. So you don't need to do this manually. You can use Desmos calculator for that. Okay.
And when we're finding the LCD or LCM, are we going to be finding the LCD for the two numbers that share the same like measurement, like gallons, for example?
As long as they're both below, right? That's
Okay.
why they're called least common denominator.
Okay, cool.
All right, so we multiply both sides by 84. Here's what we got. Okay, what's 84 divided by 28, guys? On your calculator. So we are now on what?
3. Yeah.
PEMDAS, okay? 84 divided by 28,
Is 3.
3. Again, you can use your calculator for that. Don't forget M, that's your variable. And then what's this? 70.5 times 84 divided by 3. So you're doing your PEMDAS already, okay? So, parenthesis, exponent, multiply, and then divide. So 70.5 times 84 divided by 3. Did you get 974? Well, sorry. 70.5 divided times 84 is 974. Did you get that? Divided by 3. Got it in your calculators? The 974. Let's check it out. 70.5, 84, 3. Okay, so here it is. 70.5, oops, times, what's that? Divided by what? 3. And then in here, times what? 84. Oh, I forgot the 1, right? 1974. Okay. Did I get the 19 in there? 1974. Oh, there. 1974. 1. Okay. I didn't even notice there's a 1 in there. 1974. Okay. Then after that, what do we do? Well, we just want M. How do you get rid of that 3? Well, divide both sides by 3. Okay. So after that, what's the final answer that we got for that? Okay. What's 1974 divided by 3? it's 658 miles. Okay. So, we are where? We are in Hickory. Those who are driving like long drive, where you'll be at on after 658 miles. Because I know from here to say Florida is like 500 miles or something. Is it?
I'm gonna figure it out right now.
Texas.
Florida's
Pennsylvania?
Roughly.
Roughly.
Florida's 800.
Florida. What part of Florida are you talking about?
Was it
Orlando.
Texas?
Orlando. From here to Orlando is how much?
Oh,
About 800 miles.
800 miles, but it's 600. So let's say Georgia, Savannah, I
Yeah,
guess.
that's probably about right.
Huh?
I'll say Virginia.
Virginia. What part of Virginia? Richmond or?
I'm just gonna measure it on Google Earth.
Yeah, it's just giving you an idea like how far is this 658 miles?
Wait, no, that's probably.
It's too far, I would say. Yeah.
Um,
Because you want to visualize like how far is 658 miles, right?
I don't know miles.
Huh? Let's see. Hey Meta,
It says New York.
how many miles from Hickory, North Carolina to Savannah, Georgia?
142.
We said 658 now, okay.
302 miles. 302 miles
What
from
about the Key West?
here, Hickory to Key West, too far, I would say, right? Anyway,
I have
Google
Biscayne
Earth is in
National Park in
kilometers, but
Florida.
658
Biscayne National Park in Florida. Oh, that is, I think, near Key West already, if I'm not mistaken. Or Biscayne
No
somewhere.
idea. That's just
Okay,
what
but yeah.
it says. New York is 600 to 630 miles from here.
From here, oh yeah. New York, 600 to 600 something miles from here. So yeah, New York
So, I mean,
City.
it's a little less, but
Miami.
I guess you'd still be in the state of New York.
Let's say somewhere up of New York, like say Queens or Jamaica, like what's that? Jamaica and what else is in there? Bronx, right? Those are northern part of.
This also says Chicago, Illinois is about 670.
This is Chicago.
You could go to almost Miami.
All right. So, any questions,
Wait,
guys? We good?
Miami's a little-
Thank you all so much, and